Happy Mercedesing! Welcome to the channel Fix Your Mercedes. This is my 300th video on the channel, and as an exclusive, I would like now to start my series of videos about the KE-Jetronic. About that famous video I was talking about, in which I'm going to be telling you everything I know about KE-Jetronic, and which is going to be in 4 languages. If any of my videos help you repair your car, then please hit the button thanks. If you, you, want to be the first one to watch my videos as they're fully uploaded, then become a supporter of the channel. And if you want to watch the service manuals, then become a donor. Thanks. And if you would be kind, please, to support my Patreon, then here is the link to that site, and see you there also. So now we start with English. This is as exclusive. And now you will be seeing me sitting and reading and not looking at you, just like this. But please, the material is huge, and in this video I will tell you almost everything I know about KE-Jetronic. This is going to be something like my final exam on the college or something. So again, please don't be too hard, but I have to be reading, because as I have said, the material is really huge. So let's go to that video. Shall we? With this video, I would like to start my quadrilingual serial on the KE-Jetronic and its evolution. In fact, about the development on Mercedes cars, W126, 124, 190E, R107, and R129. I would like to demystify all the perplexities about the system, because the task of my channel is to try to demystify the system, and at the very end I will give you my objective opinion and tell you the biggest advantage as well as disadvantage of the system. So let's get started. Unlike K-Jetronic, which remained almost the same as it was launched in 1973, except of the K-Lambda, K-A, or KE-Jetronic, which was sold on US and Swedish market. That's why the letter U for the USA. KE had many versions, 5 of them, so that this video includes the engines M102, 103, 104, 116, 117, as well as 119. The most famous car using the K-Lambda system is DeLorean. This era of the KE-Jetronic lasted from 1980 up to 1983. And then we get the KE-Jetronic system. The K-Lambda is the KE-Jetronic with lambda probe and so-called frequency valve, and then we get the KE-Jetronic. I have been speaking about the way this system functions. I can say that Germans never name anything by chance, so that the D in the word distributor stands for Druck. In L-Jetronic, the L stands for Luftmenge. In K-Jetronic, the letter K stands for kontinuierliche Kraftstoffeinspritzung, while the letter E stands for elektronisch gesteuerte Gemischanpassung. So now all of you who managed to pronounce these words in German and who are not Germans, who do not speak German, let me know that down in the comments below. The sensors send ECU the information about the engine load so that the ECU manipulates the mixture accordingly. It either enriches the mixture, makes it leaner, or it makes the fuel cutoff. Sends no fuel towards the injectors depending on the engine load. That's why good functioning sensors are required in order for the system to function the way it's supposed to. The sensors send signals to the ECU, which processes it in the form of current signal, amperage, and forwards it to the EHA for the fuel and to the idle control valve for the air, as well as to some other sensors. The setup here, measuring milliamps. So at the operating temperature, let's plug in the value 4.6 volts. And that's the point of the KE-Jetronic injection system. If you have ever asked yourselves what Jetronic stands for, it's a term for the injection system which was controlled by the ECU. The ECU controls the injection only and nothing else. In case it comes to the electrical interruptions, the EHA sends a constant ideal differential pressure while the ICV takes an ideal position in case something goes wrong on the system, and that's the point of the KE. Unlike K-Jetronic, the main modification concerns the pressure difference between the two pressures. The system pressure on the K-Jetronic was in the range up to 5.6 bar, while the working pressure was according to the engine load, so that on the cold engine the pressure difference was up to 5 bar. At 80 degrees C, the working pressure would be 4 bar at most. This means that the differential pressure was approximately 1.8 bar. Now, on the KE, the pressure difference is 0.5 bar when the engine is cold and 0.4 when the engine is warm. So the working pressure has been increased in general on the KE-Jetronic. As I have already mentioned, there were 5 versions of the system: KE1, KE2, KE3A, KE3B, as well as KE5. The KE1 was present on the oldest versions of the 190E. Let's start from the mechanical part of the system. The look of the fuel distributor has been modified. While the differential valves were visible on the upper chamber on the K-Jetronic, now they are located at the lower chamber, so they are not visible until the fuel distributor is being removed from the airflow meter. The first models of the fuel distributor can be recognized by the red-black plate with the mark MT0001, MT for German Mengenteiler. These fuel distributors were being mounted on the airflow meter with the purple-blue shield with the mark LM0001, LM from German Luftmengenmesser. The injectors were different, and they have been atomizing at a lower pressure. There is no more warm-up regulator, and instead of it we have the electro-hydraulic actuator, better known as the EHA. The fun fact: the first EHAs with a bit a different look. So everything is almost the same, just we have this part here. You see? Now, the potentiometer has been added to the system. In my opinion, the worst part engineers could have developed, because in 100% of all the failures and malfunctions on the system, the potentiometer was always the issue, as it turned out to be in my praxis. The KE1 is almost like the mechanical K-Jetronic. We still have the thermotime switch, which runs the cold start valve, a bimetallic plate with a bar, and as the plate was warming up, it would modify its position and made passage for the idle. The idle was adjusted with a flathead screwdriver,
So the thing I wanted to tell you is I have a manual idle control valve that has a screw in it. So when I screw it in, it lowers the RPM. When I screw it out, and it like goes what is it called? It increases it.
So if you ask yourselves, what was then the task of the potentiometer on the earlier systems if it did not control the idle? Well, on the earlier systems, the potentiometer had the function to tell the ECU how fast the plate was moving and which was its location. Was it here, or here, or here? And then in order for the ECU to enrich the mixture accordingly. Or it was like this, and then you drive downhill, you release the throttle, and this happens. So like this, and this, then like this. So, as they say now, this or this or this guy had to report the ECU what was happening so that the ECU could then adapt the mixture accordingly. There was an auxiliary valve which had to prevent the engine from stalling if the car was under a load or if the consumers were on. If the car was equipped with the AC, there were two of them. In the beginning, there was the coolant temperature sensor with one contact. Later, there was also the one with two contacts. One contact was connected to the ECU and the second one to the fuel pump relay. The fuel pump relay was doing what its name says, running the fuel pump, nothing else. It had 6 pins, 15, 30, 31, 50, 87 TD. The OVP had 6 pins or 7 if the car was equipped with the ABS. The ignition was the so-called Kontaktlose Transistorzündung, TSZ, which timing could be adjusted. The ECU was with 25 pins. Its reference number was 002-545-3632. The KE2 system was present in the first series of the W124 models. The fuel distributor, as well as the airflow meter and the injectors, are the same as on the KE1. The difference was only that the cold start valve was operated by the fuel pump relay. No more thermotime switch. This is the fuel pump relay from KE30 system. So here, let me show you. Here, what we have, it's contact TF. That's the contact for the temperature signal for the cold start valve. Here we have the contact 87V. That's the cold start valve actuation. Here, V. Here, what you see, 87K. That's for kick down, but since my car is manual, then I don't have kick down. Here it should be for the AC, but I also don't have AC. Here is the contact 87, which runs fuel pump, which preheats lambda. The fuel pump relay has now the TF, the temperature signal. The potentiometer was changed, which had the reference number 34305910006 or 34305910031. And they used to fail often. They had different plates. Somewhere it was white, somewhere green. Unlike the KE1, now the system has the TPS, which recognizes the wide open throttle only, while the idle is still being adjusted manually. The ICV has 3 pins. KE2 still uses the TSZ injection. The fuel pump relay does many other tasks. It operates the kickdown, preheats the lambda, runs the cold start valve. The OVP has still one fuse only, and it is voltage supply both for the ECU as well as for the ICV. The contact 87E was connected to the ECU and the second one to the central pin of the ICV. If the car was with the ABS, then both contacts 87E were connected to the ECU and ABS module, and the ICV was connected to the contact 87L, and the relay itself was different. The coolant temperature sensor was with one pin only. Now, the ECU would simulate the temperature signal, TF. The ECU was with 25 pins, as well as its reference number was 003-545-4932. The KE3A underwent many modifications. The KE3 was present on the engines M102, 103, 116, and 117. On the M102 engines, the airflow meter and the fuel distributor were modified. The fuel distributor is now labeled as MT0008, and it has a gray-black plate. By the look, it's the same as its predecessor. The only difference is that the differential pressures are being set differently, and there were some minor visual differences. The airflow meter is replaced as well, and it is recognized by its reference number LM0008. The shape of the sliders is also a bit modified. They're a bit different in comparison to those ones on LM0001. In comparison to its predecessor, it's identical from above, but from underneath, its cone part is now narrower, which means it needs less air, and that's why the fuel distributors on the systems KE1 and KE2 were adjusted to give more fuel. So be careful here to match these two units, or you will never be able to set the mixture properly. And remember, it is unnecessary, and I repeat, absolutely unnecessary to replace your fuel distributor. Bear that in mind. M103 engines had airflow meter labeled as LM0004 and the fuel distributor as MT0004. And there were no modifications here. The number on the potentiometer was ending at 015 or 017. 015 was on the M102 and 017 on the M103 engines, but they are fully compatible. Now they have a variable resistor which was not present on KE1 and KE2 potentiometers. It was not necessary because those potentiometers were not reacting so sensitive on idle. The potentiometer was not regulating idle. Afterwards, we get the universal potentiometer, which was ending on 035. We get now the intake air temperature sensor, which is located on the air filter housing on the M102 engines, and while on the M103 engines, it was mounted laterally at the rubber hose. The sensor is on the older system connected both to the ECU pin number 11 as well as to the ignition module. Its reference number was on the M116 and 117 engines, California versions. We have the altitude sensor, which is connected to the pin 11. Now, for the first time, we get some kind of a diagnostic on the X11 port in a form of percentage in case the contact number 3 on X11 was not blank. The system has now new injectors that open at a slightly higher pressure, and they are under different reference number. Now, there was a different ignition type, the so-called EZL, elektronische Zündanlage mit Zündlinienverstellung. Now, it's not possible to adjust the timing manually because it is being adjusted by itself with help of the crankshaft position sensor, which is located at the flywheel. It's only possible to make adaptations on a less quality fuel, but as we don't have leaded and unleaded fuel anymore, then just leave the sensor on the S position and there will be no mistake because that's the field for the 95 octane fuel under which the car achieves the best performance. Now there is the TPS that recognizes both closed as well as fully open throttle. The ICV has now 2 pins and it's absolutely not possible to do any manual adjustments on it. The ECU adjusts the idle based on the signal of the sensors. Primarily, the potentiometer is the one that adjusts idle. The system has now the speed sensor, which tells the ECU if the car is in motion or not, and therefore if the mixture should be decreased or not. The potentiometer has now one tiny screw on which the signal from the potentiometer can be adjusted, but it's not recommendable to be done. From the coolant temperature sensor, there is the signal which goes both to the ECU as well as to the ignition module, which goes to the TPS as well. The ECU has still 25 contacts and can be found under many reference numbers. On the KE3B, which was being mounted starting from the September 1989, we have slight modifications. The coolant temperature sensor has now 4 pins, and everything else is almost identical as on the predecessor. Their ECUs are fully compatible. The difference is in the electronic part of the system. No more program for non-cat versions of the system. On the first cold start, the ECU holds the RPM between 12 and 1500 for 28 seconds before it decreases them to the idle revs. That depends on the engine temperature. If the engine is warmer, the RPM will be lower and for shorter time, and everything in order to preheat the catalytic converter. Now we have the first form of the OBD, the OBD1, which is in the form of pulses, and that part is located by the battery, the so-called X11/4. It had 8, 16 or more contacts, depending on the equipment. Now, the contact 30A on the OVP is connected to the pin 15 on the ECU. The ECU runs constantly, and if it comes to the code, the ECU is going to report it. This can make troubles to those who mount the LPG system in the car and the code appears on lambda. The mechanical part of the system can be perfect, but although the car will run worse on gasoline after it was driven on LPG just because the ECU struggles to erase the code. The lambda is not located in the exhaust pipe anymore. Now it's in the engine bay by the manifold. In the beginning, the OVP was equipped with one only, later with two fuses. That's because the voltage supply for the ICV was connected differently. Concerning the V8 engines M116 and 117, everything is the same as for the engines M102 or M103. The only difference that the cold start valve on V8 engines operates up to 15 degrees C, while on the engines M102 and M103 it operates up to 60 degrees C. M103 engines were equipped with one fuel pump only, later they had two of them like V8 engines. Only M102 engines had a spring in the barrel. All the others not. The fuel distributor of the M103 engines had an additional screw on the upper chamber for the pressure gauge, easier to be connected without disconnecting the line for the cold start valve, which makes the job with the pressure gauge a lot easier. On the V8 engines, only the idle could be adjusted under the circumstance. There were no vacuum leaks and everything else on the system checked to be functional, and the idle was higher though. Concerning the ICV with two pins, there is indeed a little screw where something could be set, but don't touch that screw. because there it is set where the limiter is going to be if under any circumstances your engine goes into the limp mode. So if you readjust that screw, then there you're gonna then ruin, let's say it like that, the limp mode. Then the idle is going to be either too high or too low. So please don't play with that screw. The nominal value for the ICV was 1000 milliamps, while for the M102 and 103 engines 580 was the nominal value, plus minus 50 milliamps. On the system KE3B, the amperage is being measured on the ICV, which was not the case on the system KE3A, on which the nominal value was being measured in voltage, between 4 and 6.5 volts. Some later versions of the M103 engines, starting from model year 1990, got the so-called MAS, an engine unit control unit, from German Motoraggregate-Steuergerät, which controls many things now instead of the fuel pump relay. Concerning the MAS, it had 22 contacts. It was present in W124 as well as in the R129 and 190E engines, M103, 104, 119. From model year 1990, the M103 engines have MAS and the ECU with 55 contacts. The engines M103.948, 942 and M103 981, 983, 985. The system KE5 underwent many modifications. This system was present on the engines M104 and 119. The airflow meter has now a different look. The plate was not flat. It's labeled as LM0010, while the fuel distributor as MT0010. The system pressure was now 6.4 bar in general. The injectors are different and their opening pressure is 4.7 bar now. The cold start valve operates up to 70 degrees C. The fuel pressure regulator can be recognized by a blue dot. The fuel distributor is the same as on the engine M103. The only difference is that the barrel inside the fuel distributor has 2 slits instead of 1. The first one is for the idle and a normal engine load, while fuel is flowing through the second slit in case of full load. Concerning the ICV, unlike previous system in which the power supply of the ICV was the OVP, contact 87L, and the ground is on the ECU, on KE5 both the power supply as the ground are connected to the ECU. Pin number 4 for the power supply and pin 23 for the ground. So as you see here, you can see that this is the example for M103 engines. But don't worry, the contacts are the same both for M103 as well as for M104 engines. So don't worry about that. The engine has a bit more sensors. We have electronic accelerator as well, knock sensors, camshaft position sensor. The ECU has now 55 contacts. Its reference number is 006545462. The vehicles with ASR do not have now the micro switch. The ones without ASR still have it. So that would be everything about the mechanically electronic port injection system that had been lasting for 10 years. It debuted in 1973 in Porsche Targa as K-Jetronic and ended up in Mercedes vehicles. The system was ingenious because of its reliability and practicality. Each component on the system could be repaired using common tools in the yard of your home or in front of your gate, at the street, on the sidewalk. But because of ecologic demands during the warm-up phase, it had to go in history. Nothing could stop this system from functioning except the crankshaft position sensor. Reliable, economic are its synonyms, although in the present time the KE requests an owner who is going to be able to repair it him or herself, because the mechanic would have to diagnose the failure. The symptoms are almost identical for different components, so bear in mind that you will have to spend at least one working day to diagnose the issue, and in this present time, it is a lot of time. For some parts, in order to repair them fully, you would have to spend up to 9 hours. Just imagine working for 8 hours searching for the failure and you achieve nothing. If you were a professional mechanic, it would be a huge waste of time for you, and that's why no one wants to repair the K and KE-Jetronic anymore. Just imagine that you're working a whole day long for nothing, and literally for nothing, in the time when the cars tell you where the issue lies. That's why no one even wants to learn about the KE. Either that or the mechanic is simply going to replace everything and charge you a little fortune. Nothing is unsolvable or too complicated to be mastered, as well as the KE. But today we live in a time when everything has to be fast and in about half an hour solved on your car. This is unfortunately the biggest disadvantage of the system. One more evil for these cars is ethanol. For all of you who drive these cars, don't let ethanol for too long in your system, because it is going to create a mesh and to clog the filters inside your fuel distributor. The result: bad idle, and you would have to be disassembling the fuel distributor all the time and to clean it. The same goes for K-Jetronic and its warm-up regulator. Either avoid ethanol-containing fuel if you can, or don't let ethanol for too long time in your cars. I hate to say this, but looks like everything in its time, because this system was created when ethanol was not added into fuel. I think that this video is a good source of education for all those who love their Mercedes cars from the era between 1973 and 1993. And with the help of this video and many more on the channel, they can get their precious cars back on the road and enjoy the right quality these cars provide. Thank you very much for your attention. So, if you liked this video,
please consider subscribing to our YouTube channel and click the bell to be notified when we post new videos.
Then I would kindly ask you not to hit the button skip ad. That is going to help me a lot. And till some next one, happy Mercedesing. Bye.